Welcome back to the deep dive. If you've ever watched a really crucial putt, I mean, the one that truly matters, and you see it take this unexpected little hop right off the putter face,
hmm
or just wobbles for a second, you know that feeling,
Yeah.
right? That instant feeling of regret.
Oh, absolutely. You know the putt is doomed before it's even halfway to the hole,
Exactly. And I think most golfers, even ones who really know the game, we all operate on this one sort of fundamental assumption.
which is that the ball just starts rolling cleanly.
Perfectly.
No.
The second the putter hits it, it's in a perfect forward roll.
And that assumption is precisely what we're here to break down.
Right.
It's what stands between, an average player and truly elite consistency.
Right.
The mechanics that happen in those first few milliseconds, they are maybe the most critical in the entire game. If you get that first moment wrong, the rest of the shot is just compromised.
That's our mission for this deep dive then. We're going to get into that hidden super fast sequence right after impact, and we're going to use some really detailed data, high-tech measurements from professionals.
Specifically, from analysis using the Quintic ball roll system.
Yes. We want to understand why your ball might be acting like a tiny pinball before it even covers, a foot of ground.
We're basically giving you the expert level shortcut here.
Right.
This is concrete knowledge on what the pros are tracking and, more importantly, how they manipulate physics to make sure every single putt starts with the most predictability possible.
Okay, so let's start with the big one, the surprise nugget that I think shocks a lot of people. A golf ball does not just start rolling.
Not even close.
It has to complete this whole sequence first, a four-step sequence, before it finds what we call true roll. So what are these mandatory phases?
Okay, so there are 4 of them, and they're unavoidable anytime you strike a ball on grass, even if they happen incredibly fast. First up, you have the launch phase. Yes, launch. This is the moment the ball actually lifts away from the putter and slightly up off the surface of the green.
Wait a second, lifts. So you're telling me even a perfectly struck putt has a little bit of airtime?
It has a vertical dimension, yes. Now, it's typically minimal, but it's there. And right after that comes phase 2, the dreaded skid phase.
Okay, that sounds bad.
It is. This is where the ball is mostly just sliding or gliding along the top of the green. It doesn't have enough forward rotation yet to match how fast it's moving forward. It's being pushed, not rolled. It's literally scraping against the grass.
And that scraping, I have to assume that's where all the unpredictability comes from.
That's exactly it. When the ball is skidding, it's just so susceptible to everything. Tiny imperfections in the green, the grain of the grass, even, microscopic debris. You lose control of your line and your speed right there.
Okay, so if it's sliding, how does it ever get into a proper roll?
Well, that brings us to phase 3, the transition phase. The friction from the green starts to slow that forward slide down, and that allows the rotational movement, the top spin you put on it with the putter, to finally take over.
Ah, so the spin catches up to the speed.
Precisely. And only after those 3 steps are done do we finally get to phase 4. True roll. That's the magic moment. It's where the rotational speed perfectly matches the forward speed, and the ball is rolling purely end over end with 0 slippage.
That is a fantastic breakdown. So what you're really telling me is that this whole expensive high-tech world of professional putting analysis, it's all dedicated to one thing, making that unpredictable skid phase as short as humanly possible?
That's the whole game. True roll is the goal because it's the state of maximum predictability.
Yeah.
Look, if a ball skids for 5 feet, you have 5 feet of potential wobbles and deflections.
But if it only skids for 5 inches?
You've almost completely eliminated that outside influence.
So if minimizing the skid is the key, then we really have to focus on what happens at the very beginning, the initial conditions of the strike.
Right.
And that means zeroing in on that vertical dimension you mentioned, the launch angle. This seems like it has to be the most critical piece for controlling how long the ball skids.
It's the foundation of the whole thing. The launch angle is just the vertical path the ball takes as it leaves the putter face. And it's so crucial because what you mentioned earlier, that little nest the ball sits in.
The nest, that tiny depression the ball makes when it settles on the grass.
Exactly. If your launch angle is too low, let's say it's 0 degrees or even negative, you're not hitting the ball forward. You're effectively driving the ball down into that grass depression.
You don't clear the lip of the nest.
You don't clear it. And that causes this immediate, really aggressive interaction with the turf. Yeah. You get a severe bounce or an erratic grab, and that instantly ruins your skid distance, your line, everything.
I can picture that perfectly. It's like you're trying to drive over a little speed bump by pushing down on it. The ball just hops straight up. But hang on. If a low angle is bad, why wouldn't a pro just deal off their putter like crazy? To guarantee maximum forward spin and force it to rotate immediately, why not aim for almost zero launch?
That is a fantastic question, and it really gets to the nuance of the physics here. While, yeah, aggressive delofting can maximize topspin, if that angle is too low, you just hit the ground first. You need that slight upward launch to clear the surface cleanly.
To fly over the very top of the grass blades?
To essentially fly over them, yes. If you drive it down, you're creating friction, not roll.
So the goal is to kiss the top of the grass, not dig into it. And what about the other extreme, going too high?
If the launch angle is too high, well, now the ball is airborne for too long. Even just half an inch of flight means that when it lands, you're introducing a whole new variable, the landing spot, which, again, just leads to inconsistency. We're looking for a very, very narrow Goldilocks window.
Okay, give us the numbers. What are the pros living by? What is that ideal data-backed range?
The measurable professional sweet spot, and this is confirmed by countless Quintic sessions, is a launch angle between 0.75 degrees and 2.5 degrees.
Wow.
It's tiny, but that range ensures the ball clears the nest, gets the right topspin, and minimizes flight time. Anything outside of that, you're starting the putt with a serious handicap.
That's an impossibly tight window, which I guess naturally leads us to the technology. If this is all happening in microseconds and measured in fractions of a degree, how on earth does an analysis system even capture it?
Right.
Let's dive into phase 3, the Quintic system.
What's so fascinating about Quintic is that it fundamentally changed professional putting because it proved we could measure what everyone just thought was, intuitive feel.
Yeah.
It doesn't just track speed. It tracks the entire three-dimensional relationship between the putter and the ball.
So walk us through the setup. It's got to be more than just a camera on a tripod, right?
Oh, it's basically a high-speed motion capture studio that's focused on a tiny patch of grass. You have a specialized camera running anywhere from 360 to over 1,000 frames per second, aligned perfectly with the target line.
1,000 frames a second.
But the secret sauce, it's the reflective dots. They place these tiny markers on very specific points on both the putter head and the golf ball itself.
So you're basically turning the club and the ball into high-speed data beacons. Why do you need a frame rate that high?
Because the entire launch sequence, the launch itself, the peak of the bounce, the moment it transitions, all of that can happen in under 1/10 of a second. The high frame rate is the only way to track the precise curvature of the ball's departure and see exactly how it interacts with the surface. You get thousands of data points on every single putt.
And what are the, say, 4 crucial variables the system is tracking related to that launch sequence?
Well, beyond just raw speed, it's tracking the 4 pillars of predictability. First, the initial launch angle we've been talking about. Second, the flight angle, which is the actual path the ball takes, including any bounces or dives from hitting the turf.
Okay, so launch is the intent, flight is the reality.
Perfect way to put it. Third is the skid distance, the exact length it slides. And fourth is the time to true roll, how many milliseconds it takes to start rolling purely.
So if you zoom out from all that data, what does it all tell you? What is the ultimate mark of an elite, perfectly struck putt?
The hallmark is a very short skid distance and an almost perfect alignment between that launch angle and the flight angle. When the forward spin and forward motion sync up, true roll is achieved. And the very best players in the world, the guys who make putts under pressure, they achieve true roll within 10 to 15 centimeters after impact.
10 to 15 centimeter, that's what, 4 to 6 inches?
That's it. It's almost instantaneous.
That is incredible. To put that in context, the average weekend golfer, they might still be skidding and bouncing a foot, maybe 2 feet down the line. Easily.
Which means over a 6-foot putt, the pro has achieved predictability for almost the entire journey, while the amateur is still fighting irregularity for a third of it. That's the difference between making 90% and 95% of those critical 5-footers.
Exactly. And that brings us to the real power of the system in practice. This is where the data actually becomes a stroke saver.
Okay, let's move to phase 4 then, the diagnostic side. You said the comparison between launch angle and flight angle is the key. So a smaller difference means a better putt.
Absolutely. If those two numbers are really far apart, it's a huge red flag that the putt is flawed. It means the ball's actual path, the flight angle, is being dictated more by the green surface than by your strike. It tells us you have poor loft delivery, an unstable stroke, or you're just driving the ball into the ground.
Let's talk about that case study from the source material. There was a player whose launch angle looked okay on paper, but it was actually masking a huge problem. This is a fascinating case, a very accomplished player, but their distance control was just erratic. Their average Measured launch angle was really low, around 0.5 degrees.
Which is close to that 0.75 floor, so you'd think, okay, maybe not ideal, but not terrible.
That's what they thought. But when we analyzed the flight angle, it was clear there was a major issue.
So what did the flight angle show?
It showed a difference of over 1.5 degrees between the measured launch angle and the actual flight angle.
Whoa.
And visually, the high-speed camera showed the ball wasn't flying cleanly at all. It was being compressed against the turf and then springing up in this slight, aggressive bounce. The skid distance was all over the map.
Help me picture that 1.5-degree gap. Is that like hitting a tiny invisible molehill right after you hit the ball?
That is a perfect visual. The gap shows you the degree to which the grass is fighting the ball's intended flight. That 0.5-degree launch just wasn't enough to lift the ball cleanly out of that nest before the putter was done pushing it. The result was this compromised, bouncing skid phase they just couldn't control.
And that is the difference between feel and science right there. So how did they fix something that's measured in hundredths of a degree?
You use the data to inform the mechanical adjustments. We saw the player was delivering the putter with a huge amount of forward shaft lean at impact. He was driving the loft down to that 0.5 degrees, even though the putter itself had more static loft built in.
So the player was literally fighting their own equipment.
Correct. The fix was twofold. First, we slightly increased the static loft of his putter. And second, we worked on reducing his excessive forward shaft lean at impact. By doing that, they got him consistently delivering a launch angle right in the middle of that ideal range, closer to 1.5 degrees.
And the proof was in the pudding. Did the angles finally line up?
They aligned almost exactly. Once the launch angle and the flight angle were tightly correlated, that uncontrolled bounce just disappeared. The skid phase shortened dramatically.
And the result was?
Instant consistency. Much better distance control. And this wasn't some big, uncomfortable swing change. It was about solving a micromechanical problem that was completely invisible to the naked eye.
That is fantastic. Okay, so for the listener, not everyone has access to a 1,000 frames per second camera.
Right.
But he can still influence these dynamics. Let's summarize the 5 key factors that a golfer can control to optimize their launch.
Absolutely. When we analyze this, we look at everything that dictates that first vertical move.
Starting with the tool itself, the putter.
Number 1.
Yeah.
The static loft of the putter. That's the fixed angle built into the face. Too much, you pop it up. Too little, and you drive it down.
But as we just heard, the static loft can be completely overridden by the player.
And that is number 2. And frankly, this is the biggest variable for most amateurs. Shaft lean at impact. If you lean the shaft forward toward the target too much, you are reducing the loft you deliver. Lean it back, you add loft. For most amateurs struggling with bounce, excessive forward lean is the number 1 culprit.
So an average golfer might buy a putter with, say, 3 degrees of loft. But because they press their hands so far forward, they're actually delivering only 0.5 degrees.
Precisely. They're unwittingly turning a good putter into a bad one that just hits the ground. That delivery angle is what really matters.
What about where on the face you hit it?
Number 3, strike location on the face. Hitting it high or low on the putter face. It subtly but definitely affects the angle of departure and the spin rate, which influences how fast you get to true roll.
And then there are the external factors we can't always control, but we have to account for.
Right. Number 4, the green surface and grain. Softer, slower greens are going to increase that interaction between the ball and the grass, which means your launch dynamics are even more critical.
Because the turf is grabby.
It's grabby. And number 5, the ball type and compression. Firmer golf balls tend to bounce more if the launch angle isn't spot on. They react more dramatically.
So the power of a system like Quintic is that it just brings all of that together, the club's movement, the ball's movement, and gives you real actionable feedback. It turns a vague problem like, my putts bounce sometimes, into a solvable equation.
It connects the micro adjustment to the macro result. That's the key.
Okay, let's wrap this up. Let's summarize the key takeaways from this deep dive.
First thing, forget the myth of immediate roll. You have to remember the sequence. It's always launch, then skid, then true roll. Your job is to minimize that skid.
Second, consistency is locked inside that incredibly narrow launch angle window of 0.75 to 2.5 degrees. That is the data-backed sweet spot.
And third, the whole point of all this tech, the whole goal, is to shorten that skid phase. Elite performance means getting to true roll within 10 to 15 centimeters of impact. That consistency is what separates great from good.
So if the entire goal of putting, whether you're a pro or an amateur, is just predictability and control, consider this.
Hmm.
We saw how a professional needed micro adjustments, measured in fractions of a degree, just to clean up the first 6 inches of their roll. The question for you is, what unmeasured, maybe large variable in your own stroke, be it excessive shaft lean, a bad strike location, or an unstable follow-through, might be causing the most surprising and damaging irregularity in your putting that you aren't even aware exists?
Hmm.
Something to think about next time you're standing over that 3-footer.